take to the love, y'all.
Killing people dying, children hurt, hanging and crying. When you practice what you preach, but you turn the other cheek. Father, 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 help us, send some guidance from us.
Alright guys, welcome to another episode of Brand Academy. Okay, as always, my name is Brand. I am Mr. Wynn's twin brother. So let's get started with our new lesson. Today we are talking about the law of cosines. Okay, so let me get rid of my beautiful face. Bam. Alright, so the law of cosines. Before, kind of just reflecting back right here. Before, right, we talked about trig ratios, our sine, cosine, tangent. And remember, we can only use that for right triangles. And then later we leveled up and we talked about the law of sines, which can be used for any triangle. But specifically speaking, we only use it when we're given two angles, right? Either angle, angle, side, or angle, side, angle. And of course, we did learn about the ambiguous case anytime we have as. And now for today, we'll be talking about the law of cosine, which, please write below here, which can be used for any triangle. Be used for any triangle. But specifically speaking, it is when we are given side, 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 or side, angle, side, where this angle here is that included angle, okay? The angle in between the two sides. So we're actually going to jump straight to the formulas. There is actually a formal way to prove it. It's just very long, and we can talk about that tomorrow in class or something. But so let's kind of just jump straight to the formula. So this is used anytime we're given a triangle. Okay, it doesn't have to be a right triangle. So just labeling the diagram right here. Let's just label the opposite sides, right? So angle A is the opposite side is A. This is lowercase b and lowercase c. Okay. So having that, the formula for law of cosine, I'm just gonna put a little note here. It's a bit similar to our Pythagorean theorem, which is the a squared plus b squared equals c squared. Okay, it's kind of similar, but not exact. Okay, so these three formulas are going to be very identical to each other with just some minor tweaks. So our first one is our a squared. I'm going to switch color here for a reason that I will explain soon. So I have a squared equals b squared plus c squared minus 2bc times cosine of angle A. So that's our first formula. Now for our second formula, we're going to have b squared equals a squared plus c squared minus 2ac times cosine. Anybody want to take a guess? All right, good job. Cosine of angle B. And our last formula is going to be our c squared equals a squared plus b squared minus 2ab times cosine of angle C. So these three formulas, if you guys can't tell already, the variables on the outside, right, correspond to each other in terms of this is the side and this is the opposite angle, right? So they're always going to be the same, whichever formula you're going to use. And of course, all of the variables in the middle, all of these variables, we just call them the other variables, right? As you can see, there's no c included. So whichever variable you choose to solve for, let's say I'm choosing to solve for side c, then we know we're going to be plugging in angle c, and everything else in the middle will be the other variables, okay? So let's get a little practice with this. Reading the first example here. So given A equals 9, B equals 11, and C, capital C, equals 28 degrees, solve for the remaining parts of the triangle, which are these three right here. So let's start off by just drawing the diagram. Draw a little sketch here. I'm going to label this triangle A, B, C. And again, C is 28 degrees. Our B is 11, opposite of angle B. And our A equals 9. Okay, we're trying to solve for our C here. So just by looking at this is a side angle side, right? We're given a side, an angle, and a side. So we know here to use law of cosine. And so since we're trying to solve for C, the formula we're going to use is our C squared equals A squared plus B squared minus 2AB times cosine of C. Okay. And then from here, you really just plug in our values. So if you guys can just pause the video here and then plug in your values and see what you get for side C. Okay, so simplifying our equation there, our C should equal approximately 5.2. Okay, so our C here is about 5.2. I'll write it in that triangle. So now, are we done? No, Mr. Wynn, we are not done. We also need to solve for angle A and angle B. So to do that, we're going to do a little, throwback Thursday. So we're going to use law of sine to find, to find the angle opposite the smaller side. Okay, the reason why we have to do it find the smaller side is because when we're dealing with acute triangles, right, it just helps us not deal with the ambiguous case as much. So using the smaller side, it will be safer, because if we're using the bigger side, we might have multiple cases, okay? So using the smaller side, I'll be writing it right here in green. So we're going to have sine of angle A, right, which that's the smaller one out of 9 and 11. So sine of angle A over 9 should equal sine of 28 over 5.2. Okay, so simplifying this, I will have over here, it should be sine of angle A should be equal to 9 times sine of 28 over 5.2, where angle A should be about 54.3 degrees. Okay. So over here is 54.3. So lastly, to find angle B, we just subtract the two angles from 180, and angle B should be about 97.7. Okay. 97.7. Okay. That is your first example there. All right. So I'm going to pause the video here. Okay, try the second example on your own. For this case, you're finding the largest angle. Okay, so it's going to be a little bit different from finding the sides. So see what formula for law of cosines you will be using. Okay, so please pause the video right here for a bit. All right, so this is the diagram that I drew. In this case, we're given side, side, side. And if our goal is to find the largest angle, we know that's going to be from the opposite side. So we're going to try to solve for angle C, right? So we'll be using the formula solving for angle C. So right now, let's just plug in all the values that we know. So we know our C is 15, so 15 squared equals 13 squared plus 14 squared minus 2 times 13 times 14 times cosine of 15. Oh no, sorry. Cosine of C, we don't know what that is. Okay, so from here, right, you have an equation and your goal is to solve for whatever angle C is. Okay, so pause the video real quick and simplify this equation. All right, so your final answer should be angle C is approximately 67.4 degrees. Just looking at the steps here. I do want to highlight this step right here. So a common mistake that students make is they end up doing 365 minus 364. So they think it would just be 225 equals cosine of C, right? So we know that this is not true since this is not true because that 364, this 364 is attached to that cosine C. So since it's attached to that cosine C, you cannot subtract it from 365. Okay? All right. That is it for notes. Hope you guys have a great day, and I'll see you guys tomorrow. Or I mean, Mr. Wynn will see you guys tomorrow.